So I'm going to start off by talking about something called an alternate exterior angle. So when you have an angle that is outside, like this green one here in this diagram, we call this an exterior angle, okay? It's if you were to extend the side of the triangle, the angle that's made from that extended side and the other side is called an exterior angle. All right. All the angles inside are interior angles. Now, what's a very cool property about exterior angles is they're equal to the addition of the alternate interior angles. Okay? So this angle on the outside is equal to the addition of these two angles. Okay? And if you think about it, that makes sense. Like if I look at this angle here, it's a 70-degree angle. Okay? This angle down here is 70 degrees. Well, to find the green angle on the outside, I would do 180 minus 70, which makes it 110 degrees. Okay? So this green angle is 110. Now, let's think about this triangle that we have. If I know this angle is 70 degrees, well, what are these other two angles equal? Well, I would do 180 because all three angles equal 180. I'd subtract 70, and that would tell me that these two angles have to equal 110 degrees. Okay, so I'm using the same math, but again, different properties. I'm using the fact that we have a linear pair between this interior and exterior angle, but I'm using the fact that all three angles add up to 180 to find what these two angles are going to equal over here. But it's the same math, same answer. 110 here, these two angles also equal 110. Okay, let's see how this applies to a problem. So here we've got an angle on the outside that's 3x plus 3, and the two alternate interior angles are 95 and x minus 10. Well, I know that this angle, the exterior, is equal to the addition of the alternate interiors. All right, so I can do 3x plus 3 equals 95 plus x minus 10. Well, if I combine my like terms over here, I get x plus 85. If I subtract 3 from both sides, let's see, 85 minus 3 is 82. If I subtract x from both sides, I get 2x on the left. And when I divide by 2, we get x equals 41. Okay, that's how we'd solve this first one. If we take a look at the second one, now this one, they're using a couple different properties here, but the fact that I see we got these two sides that are the same makes this triangle isosceles. Okay, makes this triangle isosceles. So I can actually figure out that if that's 2x, because it's across from this congruent side, this angle would be the same angle because it's across from this congruent side. So it's also 2x. All right, so I could do 130. My exterior angle equals the remote interior angles added together, 2x plus 2x, which is 4x. All right. Now, when I divide by 4 here, I think I'm actually going to get a decimal, but I think it's x is going to equal 32.5. Okay. All right. Triangle inequalities. That's what the majority of this objective is going to be about. Let's go ahead and move on. So, if sides on a triangle are not congruent, then the largest angle is across from the largest side, and the smallest angle is across from the smallest side. All right. So in this case, our smallest side is 3, therefore B is the smallest angle. The next smallest side is 6.5, so directly across from that, A would be the second or the middle sized angle. And then since 9.2 is the largest side, C is the largest angle. Now, I don't have to mark these single, double, triple. I just did that because I went from smallest to biggest. but they do correspond. Smallest angle, straight across from the smallest side. The middle angle, straight across from the middle side. Biggest angle, straight across from the biggest side. Okay. If angles on a triangle are not congruent, then the largest side is across from the largest angle, the smallest side across from the smallest angle. Same idea, just going the other direction. So we know I'm going to go smallest to biggest again. Smallest angle, right across from it, smallest side. Middle angle, right across from that, second longest side. Biggest angle, straight across from that, would be the longest side. Okay. It just helps out if you're given a triangle and you know the angle measures and the sides, but you don't have a diagram for it, you could actually place them into a diagram based on this information. Write the angle measures below from least to greatest. Here's why I'd want to do that. Well, I want to identify them first. So let's find my smallest side because it says from least to greatest. So let's see, smallest side is this one, 4.85. Looks like C is the smallest angle. So I go angle C is less than. Next biggest angle, this one, 9.05. So angle B. And then the last one would be the biggest side points to the biggest angle, angle A. Okay. Now, if you wanted to, you could probably put a little m in front of it. The measure of angle C is less than the measure of angle B, which is less than the measure of angle A. Least to greatest. Okay. Least to greatest. All right. Side lengths from shortest to longest. Same idea. Let's go from the smallest angle. There's our shortest side, AB. Now, in this case, we don't have to write the measure of AB. If we just write AB, that's talking about the length between A and B. AB. And the next biggest one would be BC. And lastly, AC. There we go. There's our sides from shortest to longest. Okay, triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. This makes a lot of sense. Okay, this makes a lot of sense. We're basically saying that the length of AB plus the length of BC has to be bigger than the length of AC. And that makes sense because if I put in some lengths here, let's say we had 2 and 5, all right? Well, 2 plus 5, it has to be bigger than this third length. Now, if this third length was, I don't know, let's say the third length was 6, all right? Well, that wouldn't, well, no, that would work. 2, 5, 6, that would work. I meant to go the other direction. Let's say it was 8. Okay. Now this isn't possible. Okay. This is not possible because if I were to put 2 and 5 right next to each other and put them out, 2 and 5, and then the segment length of 8, 8's going to be longer because 2 plus 5 is 7, and 8's longer. So it'd be impossible for these two sides to stretch long enough to meet a side length of 8. All right. But we know that as long as this is bigger than the third side, then you're good. So if it was 6, 6 would work, all right, because 2 plus 5 is 7, which is bigger than 6. So that works, all right? You'll know that you'll be able to know that there's a problem if you did have a length like 8, and that didn't work. So can a triangle have side lengths of 20 inches, 20 inches, and 20 inches? Yes, it can. And we know that because 20 plus 20 is greater than 20. All right. So we know that that does work. But it's also, we're talking about an equilateral, equiangular triangle. All right. Because we have 3 congruent sides. Can a triangle have side lengths of 8, 6, and 15? So you take the 2 smaller ones, 6 plus 8 Is that greater than 15? No, 6 plus 8 is 14. This is not true, which means this cannot happen. Come on. There we go. Can a triangle have side lengths of 20 inches, 12 inches, and 32? So we got 20 plus 12. Is that greater than 32? Well, 20 plus 12 is 32. This isn't greater than or equal to. It has to be bigger than 32. So this cannot happen. That's a no. Basically, if I were to stretch these out, okay, I'd have to lay these completely flat for them to work, and I would just end up with a line. All right, I wouldn't have a triangle. There'd be no space in that triangle. So this situation cannot happen. So no, you cannot have a triangle with those lengths. All right, if a triangle has one side length of 5 centimeters and another length of 11, what are the possible lengths for the third side? This is important, okay, because this talks about not only how big the third side can be, but also how small. Now we know how big it can be because we know that the third side can't be bigger than 5 plus 11. It can't be bigger than 16. All right, so we know 16 is kind of our max. But let's talk about what the smaller side can be. Let's draw a little triangle here. If I had a triangle that was, let's say it's really acute. You have an acute angle here. So this is my 5 length. That's my 11 length. Actually, I made this obtuse, didn't I? This is the example where no, I did this right. So I make the really small angle here. This third side here, let me see if I can actually do a picture here because my triangles are not turning out very good. There we go. All right, so we got our length of 5, length of 11. So you see this third length, all right, this third length with 5 and 11, if I were to make this even smaller, okay, if I were to make that even smaller down here, 5 would eventually get really close here, and that length that would be left would be about 6, okay? So the way I can find the smallest length that that third side can be is subtracting these two. So you take the bigger one, the bigger side of the two you're given, 11 minus the smaller one, and that tells you it has to be bigger than 6, okay? So it looks like our two side lengths have to be bigger than 6, less than 16. Here's how I'd write that. 6. Let's see. I'm going to put x just to use a variable, and 16. This tells me that the third side, if I were to name it a variable, we're going to name it x, has to be bigger than 6, and less than 16. So it has to be a little bit bigger than 6 and a little less than 16. Anywhere in between there would work for the triangle. Now again, how the triangle looks would be a little different. This is an example of the triangle. Oh, it has to be bigger than 6, so let's make it 7. This is an example of how it would look in this situation. The situation where you'd have one closer to 16, the triangle would look like this. You'd have a side length of 5, a side length of 11, then you have a really long side like that to make it 15. So you're kind of, this side can kind of pivot back and forth a little bit. If a triangle has two side lengths of 10 and 10, what are the possible lengths for the third side? Well, again, here's how you find your sides. I'm going to write this down here. I've got x. All right. I know the smallest number goes down here, the bigger one goes here. To find that bigger one, you add them together. We know it's got to be less than 20. Okay? You add them together and it's got to be less than 20. Because if we're bigger than 20, you put these two sides together, they wouldn't reach the end. To find your smaller number, you subtract. Well, this has to be bigger than 0. So these examples, the smaller one, it'd basically be if you had 10 and 10. Well, that third side, if you made these two sides super close together, it just has to be bigger than 0. All right? So we can make it 1. All right? 1 would work. Now, the other example is if you had the really big isosceles triangle where you had 10, 10, and this third side would be getting close to 20. We'll say 18. All right? But again, to get your biggest possible length, you add them together. To get the smallest possible length, you subtract. Stephen was given 9 feet of wire and told to bend it into the shape of an isosceles triangle. Sketch an isosceles triangle that Stephen could have formed with 9 feet of wire. There is more than one answer. I'd say let's do the easiest one in my head is an isosceles triangle where you've got, well, I think, you know what we need to do first? Because in my head, I'm like, well, we'll just do one that's 1, 1, and 8. Well, that's not possible because 1 plus 1 isn't bigger than 8. So that doesn't work. Let's go ahead and do what we did on that last slide just to see what our different lengths. Well, you know what? Let's just keep, I'm going to keep guessing, checking. 2, 2, and 5. 2 plus 2. Nope. That doesn't work. 3, 3, and 3. That works. This is an equilateral triangle, but it's also isosceles because it has at least 2 congruent sides. So this one works. Let's see the last one here. Can we do 4, 4, and 1? Does that work? Let's see. 1 plus 4 is bigger than 4. Yep. 4, and then you can do the other direction. 4 minus 4 is 1's bigger than 0. Yeah, this works. 4, 4, and 1 also works.